Hello everyone, welcome back to our YouTube channel schoolquiz.com. My name is Danish Agarwal. Today we will discuss about chapter 3, that is atoms and molecules. In the previous video we have discussed about two main laws or laws of chemical combination, that is first one is law of conservation of mass and other one is law of constant proportions, and we have already discussed what are atoms and what are molecules. Now we will discuss about Dalton's atomic theory. Now we will discuss about Dalton's atomic theory. Very important. Dalton's atomic theory. Dalton's atomic theory. So it has given six postulates. It has given six postulates. In your NCRT, we will discuss all six postulates one by one. First postulate is all matter is made up of tiny particles. All matter is made up of tiny particles called atoms. All matter is made up of tiny particles called atoms. As you have already know what is matter. What is matter? Anything which occupies space and has mass is known as matter. For example, this marker, it's a matter. This whiteboard is also a matter. And matter is made up of very tiny particles called atoms. Okay. Next postulate is atoms are indivisible particles. Atoms are indivisible particles. Atoms are indivisible particles which cannot be created, which cannot be created, or destroyed in a chemical reaction. Atoms are indivisible particles. Indivisible matlab which cannot be further divided. So atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Which can neither be created nor destroyed in a chemical reaction. Okay, next postulate is third postulate is according to third postulate is atoms of a given element are identical in mass. Atoms of given element are identical in mass and chemical properties. Atoms of given element are identical in mass and chemical properties. For example, if we take sodium, so suppose it is a block of sodium and here are many atoms are present. So all atoms mass is same. And the chemical properties is also same. For example, sodium atomic number is 11, mass is 23. Another one is also sodium atomic number 11 and mass is 23. They are identical in mass, that is their mass will be same and the chemical properties are same. For example, it will also lose one electron. This atom will also lose one electron. Okay, atoms of the same element are identical in mass and in chemical properties. Okay, now we will move to our fourth postulate. Fourth postulate is atoms of different elements. Here was same element. Here was same element and here we will take atoms of different element. Atoms of different element element have different masses, have different masses, atoms of different elements have different masses and chemical properties and chemical properties. Naturally, if the element is different and its atomic mass will be different and its properties will also be different. For example, if we take molecule of, suppose we have water molecule, here is one hydrogen and there are two oxygen. So oxygen atomic number is 1 and mass number is also 1, whereas oxygen is 8, 16. Its property is different, its property is different. For example, if we take sodium 11 or if we take chlorine 17, sodium will gain 1 electron, whereas chlorine will gain electron, whereas sodium will lose electron, and their masses and chemical properties are is also different. If we take different element, if we have different elements, their masses and chemical properties will be different. Okay. Now we will move to a fifth postulate. Fifth postulate. Our fifth postulate is atoms combine combine atoms combine in the ratio of atoms combine in the ratio of small whole numbers. Atoms combine in the ratio of small whole numbers to form compounds. For example, if we take molecule of water, as we have already discussed, for example, its ratio by atoms is 2:1 and by mass is 2:16, or we can write it as 1:8. There is a whole number ratio. Whole numbers are what? What are whole numbers? 0, 1, 2, up to so on. So they are always combined in a whole number. For example, if we take molecule of water, it is not writing as H1 by 2, oxygen 1 by 2. So it is always a whole number. Okay. Now we will move to our sixth postulate. The relative number and kind of atoms the relative number and kinds of atoms are constant in a given compound. That is relative number and kinds of atoms. For example, if we take molecule of water, it is fixed, that is there will be two atoms of hydrogen and one atom of oxygen. No one can tell that if water molecule is, suppose we want to write formula of water, no one can write it as like H2O4, that the elements and atoms are constant. For example, we cannot write it as O2H, so it is not a water molecule. Suppose H2O2, it is hydrogen peroxide. So we can say that the relative number, for example, there are 2 and there is 1. The relative number and kinds of atoms, kinds means one is hydrogen and one is oxygen, will be constant in a given compound. It is always a constant. For example, if we talk about carbon dioxide, one atom of carbon and 2 atoms of oxygen, and it is constant. And here atoms are also constant, that is one is carbon and other one is oxygen. So these are the main 6 postulates of Dalton's atomic theory. It is important from the paper point of view. Sometimes it comes in like 2 to 3 numbers and it is very easy theory. Okay, now we will discuss about 4 blue questions, which are based on law of conservation of mass, law of constant proportions, and 2 questions are based on Dalton's atomic theory, which we will cover in this video also. Okay. Okay, next. Now we will talk about our 4 NCERT blue questions. First question says, according to first question, you can open your page number, page 82. Page 82 of NCERT class 9 science. Okay. First one is in a reaction. A reaction is given. For example, sodium carbonate. Sodium carbonate. You can watch the statement from your book. Okay. You can note down the statement from your book. Sodium carbonate plus ethanoic acid gives us sodium carbonate plus ethanoic acid gives us sodium chloride, sodium ethanoate, sodium ethanoate plus carbon dioxide plus carbon dioxide plus water. Okay, if we see the weights are given like 5.3 grams, we can write it in the form of formulas. Okay, first of all is sodium carbonate, that is Na2CO3. In the next video, we will discuss about how the chemical formulae are occurred. How can we make chemical formulae? Okay, so we will discuss in next video. That is sodium carbonate plus ethanoic acid, that is CH3COOH. It gives us sodium ethanoate, that is CH3COONA plus carbon dioxide CO2 plus water. Okay, so now weight is given 5.3 gram of 5.3 gram of sodium carbonate. Okay, next is 6 gram of ethanoic acid. 6 gram of ethanoic acid, whereas weight of sodium ethanoate is 2.2 gram. So sodium ethanoate is 8.2 gram, and CO2 is 2.2 gram, and whereas weight of water is 0.9 gram. So we have to see that this statement whether obeys law of conservation of mass or not. Okay, so we will check. What will we check? What is according to law of conservation of mass? That is mass of reactants equal to mass of products. If this mass comes out to be same of both left hand side and right hand side, then we can say that it obeys law of conservation of mass. So check. First of all, we will calculate mass of reactants. That is 5.3 plus 6 gram equal to 11.3 gram. 11.3 gram. Next is mass of products, that is 8.2 gram plus 2.2 gram plus 0.9 gram. So you can calculate, that is 11.3 gram. 11.3 gram. Okay, so you see that mass of reactants equal to mass of products. Therefore it obeys law of conservation of mass, which we have to check whether it obeys or not. Okay, now we will move to our second question. I hope this clears your question. Now we will move to our second question. Note it down. Okay, next question is, hydrogen and oxygen are combined in the ratio 1:8. Given is hydrogen and oxygen combined in the 1:8 by mass to form water. What mass of oxygen and would be regarded to complete with 3 gram of hydrogen? So we have to tell, if we have 3 gram of oxygen, 3 gram of hydrogen, we need mass of oxygen required. Mass of oxygen required. If we say that is 1 gram of hydrogen, 1 gram of hydrogen combines with 8 gram of oxygen, gram of oxygen. So simply multiply. So 3 gram of hydrogen combined with, that is 8 into 3. If we multiply this with 3, so if we also multiply with this with 3. So 24 gram. Just simply multiply by 3. Multiply by 3 and it is also multiply by 3. That is 24 gram. It is based on the question that it is based on the law, that is law of constant proportions. Now we will move to our third question. Third question. Third question. Third question says, which postulate of Dalton's atomic theory is the result of law of conservation of mass? Which postulate is responsible for the law of conservation of mass? So its answer is what? Its answer is postulate 2. Postulate 2, that is atoms are indivisible particles, indivisible particles which can neither be created, nor destroyed in a chemical reaction. If none of the atom is created, none of the atom is being destroyed, so mass will remain constant. For example, if we have first one 5 and another is also 5, then the mass will remain constant. So it means that is it to base law of conservation of mass. Now we will move to our fourth question. Fourth question says, which postulate of Dalton's atomic theory can explain law of definite proportions? Law of definite proportions. So its answer is postulate 6, which we have already discussed. Okay, postulate 6, that is the relative number and kind of atoms, the relative number and kind of atoms are constant in a given compound, are constant in a given compound. So these are all the 4 questions which we have discussed into these 2 videos, that is on the basis of laws of chemical combination and Dalton's atomic theory. So I hope this also clears your topic. If we do NCERT questions, it will enhance our knowledge, and it is also important from the paper point of view. Okay, so I hope till now what I have taught you, it will be clear to you. So thank you. I hope you like this video. Okay.